Welcome to springlib.
So the graph they're referring to in the problem looks something like this. It's a plot of v versus t, and it's got a constant v at 2 meters per second here, and then it switches to 3 meters per second here. Now, in finding the average velocity over this trip, you can refer to an equation, but I think it's easier to just use the fact that for 2/3 of the trip, we're moving at 2 meters per second. And 1/3 of the trip, we're moving 3 meters per second. And so this should give us our average velocity, and we would expect it to be somewhere between 2 and 3 meters per second, but closer to 2 because it spent more time going 2 than 3. Whenever you plug this into your calculator, you get that the average velocity for this trip is 2.33 meters per second, which sounds about right given our intuition earlier. Now we also need the average speed, and in this case, it's going to be the same thing because average speed does not care about positive or negative directions. In this case, we're moving in the positive direction for both pieces, so the average speed is also equal to 2.33 meters per second. And now we can move on to part B. In part B, our graph looks a little different. It's now going to go 2 meters per second for the first 2/3, and then it's going to dip all the way down to -3 until we get to t is equal to 3 seconds. So let me just add in the points here. This is 2, and then this y value is -3. So we find the average velocity the same way. 2/3 of the time, the velocity is 2 meters per second. And then 1/3 of the time, the velocity is now -3 meters per second. And whenever you plug this into your calculator, you get the average velocity is 0.33 meters per second. Now, the tricky part is the average speed. The average speed is actually going to be the same as these two, 2.33 meters per second. And the reason is that whenever we go -3 meters per second here, that's a switch of direction. It doesn't change the magnitude, but the speed is only cares about the magnitude. And so this -3 might as well be a +3 again, and then we're just back at the original part A situation. So speed is a scalar. It does not have a direction. So this -3 might as well be a +3. Velocity does have a direction, which is why we had to take this -3 into account. So just to write it for you, the average speed for part B is 2.33 meters per second, the same as in part A. And that should be it for this problem.